2-step question. It says to determine the balanced chemical equation for this reaction. C8H18 plus oxygen makes carbon dioxide plus water. Part A, enter the coefficients for each compound in order separated by commas. So I'll just show the balanced chemical equation. Part B, 0.280 moles of octane is allowed to react with 0.63 moles of oxygen, which is the limiting reactant. Part C, how many moles of water are produced in this reaction? And then part D, after the reaction, how much octane is left? Okay, so let's start off. Trying to balance. We have octane, gas, plus oxygen gas makes carbon dioxide plus water. Okay, so this is an example of a combustion reaction. And the reason that we know this is because combustion reactions always have like a hydrocarbon. In our case, it's the octane, and it reacts with oxygen to form carbon dioxide and water. So it will always react with oxygen, and the products will also be CO2 plus H2O. So that's how we know we have a combustion reaction. Okay, so now we want to balance this equation. So there's a method that I like to use when balancing combustion reactions. And the first one is just to balance my carbons. So when we want to balance out the carbons, you'll see that the hydrocarbon, which is octane, contains 8 carbons. So I need to write an 8 in front of CO2 so that my carbons are balanced. And then after I balanced out my carbons, next I want to balance out my hydrogens. Okay, so on the left side we have 8 hydrogens, and on the right side we have 9. We have 2, but we need to put a 9 in front so that both sides have 18. And then lastly, all my carbons and hydrogens are balanced, and now I want to balance out my oxygens. So the reason I do this last is because when I balance out my carbons, this affects the number of oxygens. And similarly, when I balance out my hydrogens, this also affects how many oxygens as well. So now that I know how many oxygens are on my product side, which is 16 plus 9, so we have 25 oxygens. On the product side, I'm going to put a 25 in front of O2 and then divide it by 2 to get in total 25 oxygens. Okay, so we're not quite done yet. Sometimes it might be easier to not read this balanced equation having a fraction. So to get rid of the fraction, I'm just going to multiply this whole thing by 2. And then I'm going to write my new balanced equation just below right here. So now we have 2 moles of octane plus 25 O2 makes 16 CO2 plus 18 H2O. Okay, so now everything should be balanced. And we can move on to part B. So part B is asking which one is the limiting reactant. Is it octane or oxygen? Okay, so the limiting reactant, I'll just write a quick definition of what it is. Basically, it's one of the reactants that runs out first. Because most of the time you won't have an equal amount of reactants, and they won't always just, when one runs out, the other one runs out. Like usually you have one that has more. So the one that runs out first is our limiting reactant. So there are different methods that people like to do to try to find out which one of their reactants is limiting. One way that I like to do is that I like to find how much product is formed if the reactant went to full completion. So basically I try to find the number of moles of one of my products, and the one that has the less amount is the limiting reactant. So let's start off with the octane first. So we have 0.280 moles of octane. And now I'm going to multiply this value by the mole ratios in order to find out the number of moles of water that is produced. So if we multiply, you'll notice that because of our balanced equation, we can see that there are 18 moles of water that is produced with every 2 moles of octane. That's why it's important to make sure that your reaction is balanced, because we can do the molar ratios and find out how much of our product we can actually form. Okay, so if we multiply 0.28 by the ratio 18/2, you should get 2.52 moles of H2O produced. Okay, so this is with octane. And now we're going to see how much 0.630 moles of oxygen will form however much water. Okay, so let's just multiply by the molar ratio of water and oxygen. So again, 18 moles of water will be produced, and the coefficient for oxygen is 25. And if we do this calculation, then you'll notice that only 0.454 moles of H2O is produced. And since it is less than how much the octane produced, then we can say that oxygen is our limiting reagent. Okay, so part C asks how many moles of water are produced in the reaction. And since the oxygen will run out first, then the reaction can't produce any more water since all the oxygen is gone. So therefore, we only produced however much the limiting reagent produced before it runs out. And we already calculated this to be 0.454 moles of H2O. So then we can just move on to part D. After the reaction, how much octane is left? So basically, we have to find the unreacted moles. So to do this, it is just your starting moles. So basically, we're trying to find out how much octane was left over if all of it reacted with the limiting oxygen. So we started off with 0.28 moles of octane. We're going to subtract how many moles reacted. So to do this, we need to multiply by the molar ratio between the limiting reactant, which is oxygen, and the octane. Okay, so it's going to be multiplied by 2 moles over 25. And then this will give us the unreacted moles. Okay, so let me just calculate this. Should get around 0.26 moles left over. Okay, so let's see what the junior tutor said. For part A, we can balance this equation by inspection, starting with carbon, then either hydrogen or oxygen, whichever is simpler. Okay, so you can see that they also got 2 moles of octane plus 25 oxygen makes 16 carbon dioxide plus 18 H2O. B, the limiting reactant, is the reactant that limits the amount of products formed. The limiting reactant is the reactant that gives the smaller amount of product. For octane, we have 2.52 moles of hydrogen produced, or water produced. And then for oxygen, they have 0.4536 moles. Therefore, the limiting reactant is oxygen. We have computed this in B. Yep. And then to answer this, we calculate for the moles of octane using the moles of H2O produced. Then we subtract the obtained amount of mole from the initial moles of octane. Okay, so they found the moles of octane that reacted by multiplying it by the molar ratio of octane and water. So this is a different method of doing that. And they got 0.0504. And for their unreacted octane, they got around 0.2296. Yep, so that's another way of doing it. I'm just going to say this solution is correct.